A dollar. You're just getting more and more extra credit. All right, are there any questions over anything that you were asked to do, homework-wise? Number 6, what page? 63. Has some fractions in there. 2x squared plus 8. That's the one? Equals negative 3x plus a half. This is number 8. Oh, number 6. Thank you. All right, so here's a question to start class. Number 6, page 63. You're asked to solve this quadratic equation. And so what do we do?
I multiply by 2 on both sides.
Okay, so you cleared the fractions. That's a good idea. If you don't like this fraction here, we'll multiply both sides of the equation by 2. Sounds good to me. So multiply everything here by 2. Everything here by 2. This 2 will distribute through the parentheses. This 2, I'm putting it on this side. Is that all right? And distribute the same way? Okay. And then this will give you 4x squared plus 16 equals negative 6x. And then half of 2 is 1. So this should multiply out to be plus 1. Do you have that much? Yes? Okay. Now, when we look at this, we're supposed to identify which case we have. So there was the first case was where we were missing an x term, which we have an x term, so it's not that one. The second term, the second case was where we're missing the constant term, but we actually have constants. So this is where we have everything, and that means we're going to move everything to one side. Did you do that next? Yes? Okay. So I'm taking it you added 6x to both sides and subtracted 1 from both sides? Okay. So I'm going to add 6x to both sides, subtract 1. So here's minus 1 under here. And I can't add 6x to anything here, so I'm just going to put plus 6x. And then you just add. On the right side, you get 0, which is what we need. And then on the left side, putting it in descending order, 4x squared minus 6x plus 15. Okay, good. So far you're there. And did you try and factor, or did you just go straight to the quadratic formula? Straight to the quadratic formula. Okay. So did you get an answer, but it didn't match up with the?
Yeah.
Okay. With the key? You same thing?
No, the 4x squared will be plus 6x or?
Oh yeah, we added, sorry. I added 6x. Thank you. Thank you for catching that. Yeah, I added 6x here. You did have plus, right? You had plus them? Okay. All right, so go straight to the quadratic formula. I'm going to be plugging into x equals negative b plus or minus the square root b squared minus 4ac all over 2a. So that's what I'm plugging into. Let me identify a, b, and c here. A is 4, b is 6, c is 15. So this formula becomes what? Negative b is negative 6 plus or minus the square root of b squared, so 6 squared, 36, minus 4 times a, which is 4, times c, which is 15, all over 2 times a, which is 2 times 4. All right, now this was the tricky part that I said you had to be careful with, and that's right here. You want to make sure that you cover up the minus sign, multiply these numbers together. That's going to be a big number. Okay, so 16 times 15. Did you find the problem?
Yeah, negative 204. I don't think that's right.
Well, then you subtract it. Yeah.
Okay, yeah.
Yeah, so this is 204. There it is. Is it 240? What is it? 240? Maybe that's the issue. Yeah, 204 didn't seem right. So did someone double check that on their calculator? 240? After you subtract, okay. So let me do that. Negative x is negative 6 plus or minus the square root. This is 36 minus 240 over 8. And then this is x equals negative 6 plus or minus 36 take away 240 is negative 204 over 8. And then I told you if you see a negative in there, you're pretty much gonna, at the point where you know you're gonna have an I. All right, so this will break down to be negative 6 plus or minus. I can just write the I out in front of the root. And the way I did that, just so everyone's clear, what I did is I took this, I split it up into root negative 1 times root 204. And then root of negative 1 is I, and then times this. So there's like a multiplication right there, all over 8. And then now we go and try and see if we can break up the 204. So see if there's any perfect squares that go into 204. Are there any? Did anyone try it? Four goes in there? 204? Yeah. So we have 4 and 51. All right? So that means I can take the square root of 204, I can break it up into the square root of 4 times the square root of 51, like this. The square root of 4 is 2. Understand? So this becomes 2 times root 51. So root 204, I'm going to rewrite it as 2 times root 51. I'm going to put that right here. It's going to be next to an I. So when I write it, I could write I times 2 times root 51 all over 8. And we normally don't write I times 2, we write 2I, just so you know. I wrote it there intentionally because I wanted you to see I'm going to switch it to 2I. And now there's just one more thing we can do, and that's we can look here, here, and here and see if they have a common factor. So 2 goes into 6, 2 goes into 2, 2 goes into 8. So we have a 2 that can go into each one of those. And you don't look at this. When you're trying to find the common factor, you ignore what's under the root completely. So I can reduce everything by a 2. Is that step okay?
Yeah.
Okay. So it'll become negative 3 plus or minus, right? This is 3. This is just a 1, so I don't need to write 1. I'll just write I again. Root 51 over, and then 2 went into this 4 times, so 4. Is that what the answer? Yeah. Yes? That's what it looks like over there? Okay. Make sense?
Yeah.
Okay, good. Yes?
I have a question on number 7 in section C.
So same page, right? Page 63. So this is the one x squared minus 2/3 x plus 8? Yep, okay. I'm kind of bummed out today because this is the Note 7. You don't know what's going on with the Note 7 right now?
It's gonna blow up.
It's going to blow up. If it blows up, then you want me to get it away from you? I'll put it down here. No, like I got the original one. I've been waiting for a year for that phone to come out. And the reason why is because I teach internet classes. So my internet students, they'll do their work and they'll take a picture of it and they'll send it to me, and then I can write on their picture and send it back. It's real easy for me to help them that way. And so I was all excited for like a year waiting for the phone to come out, and then it comes out and then they have all these problems with the battery. So I wait. I get a replacement. So I got that phone. They gave me a temporary phone. Then I got the replacement. Now I have to go take that in and get a completely different phone. So in the last 2 months, I'm gonna have switched phones 4 times. And you know how fun it is to like redo all your stuff on your phone? What a pain in the ass. All right, so I've got to go do that today. I'm real excited. All right, so what did you do here? I'm sorry, I went off topic there. What did you do? Did you just go to the quadratic formula straight with this, or did you get rid of the fractions?
I used the fraction.
You used the fractions in the formula from the quadratic, right? Okay, that's fine. So if I were doing this, I would probably multiply everything by 3. Okay, that's what I would do. But you don't have to. You have to make sure, though, that you get your A, B, and C right here. So what did you use for A here? 1. And B was negative 2/3. Did you use negative? Yes, okay. And then C is 8? Okay. All right, so my guess is that you probably did most of it right, except that your answer is going to look different than their answer. That's probably the issue, which on the test I wouldn't take off for, because I can usually look and tell like the 2 answers are the same. All right, but let's just go with this and see what happens. So I'm going to go x is negative b, right? So using the formula again, what's negative b? So it's negative, negative, right? This one's already negative. So positive 2/3 plus or minus the square root of b squared. So you have to take negative 2/3 and multiply it times itself. So when we multiply fractions, it's straight across. So this should give you 4/9, and it should be positive. Yes? 4/9 minus 4 times a times c, like that, all over 2 times a. If I cover up the minus sign there and do 4 times 1 times 8, I should get 32. So your next line should look like this: 2/3 plus or minus the square root of 4/9 minus 32 all over 2. You okay up to there? Okay. You have to put these two together, which means that you have to subtract these two, which means you have to look at this as a fraction. You have to get a common denominator.
You multiply it by 9.
Multiply top and bottom by 9. Good. So let's see what happens. So x is equal to 2/3 plus or minus the square root of 4/9 minus, what is 32 times 9? 287?
288.
288. Is it? Yeah, 288. 288. 288 over 9 over 2. And now that you have the same denominators, you can go 4 minus 288, which is negative 244? 284, sorry. Negative 284 over 9, all of this over 2. And as soon as you see that negative under there, you can pretty much eliminate the negative and just put an I out here. Have you all caught on to that? Okay, that's what I'll do on the next step. Any questions from anyone else right now? I would probably be okay with that on the test. But if we want to go further, here's what we could do. We could take this root right here, and we could break it up into 2 roots, because that's a property of radicals that you're allowed to do. If you have a fraction underneath a radical, you can split it into 2 radicals like this. I did that because I noticed the square root of 9 is just 3. So I know the bottom is 3. And then the top, I can go and try and see if I can break 284 down. So I'm going to start dividing 284 by what?
4.
By all those perfect squares, right? 4, and then I could try the different ones. So 284, it's going to go by 4, right? 71 times. So this becomes root 4, I'll do it this way, times 71, which is root 4 times root 71 over 3. Is that still okay? And then root 4 is 2. So this is 2 root 71 over 3. So I can replace this entire thing right here not the I, but this thing, with 2 root 71 over 3. So I'll do that. What should I do with that 2? That's, I'll just write it down. I'll have the I, then I'll have the 2 over 2 root 71 over 3. Now here comes the tricky part, and this is why your answer is going to look different than the solutions do. This I right here is being multiplied, isn't it? You could look at I as being I over 1. And then you can multiply straight across. And just let me write it down and just tell me if it makes sense that this would be this. All of this over 2. Does it make sense that it would be this? Yeah. That I is just really going to join the 2 up here. So I put it behind the 2. Now, do you recognize anything in the numerator? Like, do you see these both have a 3? You can actually put these together now and get 2, which is this, plus or minus the 2i root 71, all of that over a single 3, and then all of that over 2. Right? I could do that. And I could do one more thing. I'm trying to make it look like the solutions. I'm almost there. I could look at this as 2 over 1 as a fraction. So I have a fraction over a fraction. And so when you take a fraction and divide it by a fraction, it's the same as multiplying by the reciprocal. So I can take this 2 over 1, I can flip it and put it up here. We've done that before? You don't, no? You don't remember seeing that? No? You're saying no? Other people saying that? So this division by a fraction is the same as multiplication of the reciprocal of the fraction. Converting division to multiplication means you have to flip what you're dividing by over. So I converted this division to multiplication. And now just multiply straight across again. What's 1 times all this junk? It's the same thing, right? 2 plus or minus 2i root 71. And then you multiply across the bottom. 2 times 3? 6. And we're still not there. Do you see what else I can do? I can factor 2, reduce by a factor of 2. 2 goes in here once, 2 goes in here once, 2 goes in here 3 times. And we're done. 1 plus or minus I root 71 over 3. Is that what they had in the back? Or is that what the solution says? Yeah. Yes?
No, on the test, do we have to do?
No, I think I said earlier, if you would have gotten to earlier I said if you got there, I'd be okay with it. Yeah. But my suggestion to you is to clear the fractions, because it's obvious that there's a lot more work involved here, a lot more room for errors. Yes?
I cleared the fractions and multiplying everything by 3 like you said
Uh-huh.
at the beginning. I got a different answer.
Do you want to tell me what you got?
I got, after I got the 6, because I ended up with a 6 plus minus 6i square root 8 over 6.
Square root of 8?
Yeah, because
Yeah, something's off there.
there's one. I can't explain.
Yeah, you know what? You're going to need to go back through. We should have the same answers. So just go back through and double check your arithmetic on it, because that's the good thing about math, is that we should all get the same answers, even if we do it different ways. As long as we don't break any rules, we should get the same answer. Just double check your arithmetic. My guess it's that part under the square root, something went wrong with that. Or when you multiplied through by 3, something went wrong. Okay, we got to get going. It's 20 minutes, so we got to move on. So do you remember what we were doing last time? We were graphing parabolas, right? Right? That's what we were doing. So I wanted to do some more graphing of parabolas. So let's try this one. We're going to try and graph y equals negative x squared. This is what your quiz is going to be over, by the way. Graphing a parabola. So I'm going to have that quiz at the end of class. I'm going to allow you to work, I'm going to give you all the option. You can work in groups with no notes, just each other, or you can work individually with your notes. So we'll discuss that later. All right, so do you remember the steps to graphing these parabolas? Do you remember what the first step was? What was it? Just make sure it's a parabola, right? So step one, is it a parabola? In this case, yes it is, because it looks like it's supposed to look, right? This looks like ax squared plus bx plus c. Y equals that. So it is a parabola. Okay, what's the next thing we do? Does it open up or down? In this case, it opens down because what? Because there's a -1 in front of the x squared, right? That number in front of x squared is a, right? So I'm going to say a here is -1, and that's less than 0. That means that it's a negative number. Negative parabolas open down. If it were greater than 0, then it would open up. What was the next step? Vertex. And this was a formula, right? This was a formula that I gave you. For the vertex, there are two things you have to find. You first have to find h, which I gave you the formula is -b over 2a. Maybe we should have taken a minute to write down a, b, and c. I'm sorry, I should have done that in the beginning. A is -1, b is 4, c is 3. What happens if you accidentally forget like the sign on one of these, or you know what I'm saying? Like what if you mess up one of these numbers? Everything's going to be messed up after that, right? So just take a little time, make sure, double check, because you don't want to accidentally write down a as 1, and then that's going to throw everything else off. All right, so what is -b for us? -4 over 2 times a. A is -1, so there, be careful. This gives you -4 over -2. A negative divided by a negative is positive. So this should be 2. That's h. What was the other thing we had to find? H and then k. And how did we find k? Yeah, you plug this right here into the original equation for y or for x? X. You plug it in for x. So what we get is negative, how do I write that? Negative, should I put the 1 or no? Parentheses, good. 2 squared, and that means you're going to square the 2 first and then turn it into a negative. You have to be careful with that. Don't say, oh, it's a negative being squared, it's going to be positive. No, that negative out front is going to be just changing the sign of whatever this is. All right, and then I have plus 4 times 2, and then plus 3. So what happens here? This is 2 squared is 4, but then you make it negative, so minus 4. 4 times 2 is 8, and then plus 3. So you should get 7. Now remember, the vertex on our graph is a point, isn't it? So our vertex is the point 2, 7. Is our vertex. Now, is this vertex the highest point on our graph or the lowest point on our graph?
Lowest.
It's going down. Okay, so because the parabola is going down, we will have a highest point, and this is the highest point right here. What was the next step? Quick sketch. Does anyone remember why we're doing a quick sketch? To see if we even have any x-intercepts, right? We want to see if we even have any. And so we're going to draw a quick little xy axes. I'm going to put on here my vertex. So I'm going to go put this point, 2, 7. That means to the right 2, up 7. I'm somewhere up here, right? I don't have to be perfect on this just to get an idea. Right 2, up 7. And then this parabola opens down from here, doesn't it? So I know it's going to look like this, like that. So is it going to hit the x-axis? Twice, yes. We're going to have 2 x-intercepts, right? And that means I'm going to move on and find them now. So I don't recall from the notes, did I make a new, was there a step 5 that said find the x-intercepts? Or yeah, it was its own step, or was it part of step 4? Let me see. Yeah, how many x-intercepts? Okay, so 5, we're gonna see how many x-intercepts we have. So 5, we have 2 x-intercepts, right? We have 2 of them. And so how do we find x-intercepts? How do we actually find where these hit? Yes, we're going to replace y with 0. Which really means if I replace y with 0, we're setting the original parabola equal to 0. That's what we're doing. So to find the x-intercepts, next step, or we're still in the same step. What I will do is I will take the original equation. I'm going to write it negative x squared plus 4x plus 3 equals y, but y is 0, so there we go. Remember, if you're going to find an x-intercept, these points, what's the y coordinate of both of these points? 0, right? That's why we replace y with 0. Now here, we get to solve. And this is like an equation that you were asking questions on the homework about. We just have to solve this equation now. So how do you want to do this? You want to try and factor? That's fine with me. So
Can you take the negative out first?
I can take the negative out. In fact, I think that would be a smart idea. Anytime you have a negative on that first term, it usually throws people off, the negative here. Because when they do that, when they try and do this thing, they get kind of confused with it. It's just a tendency. You may be okay with it, and you can leave it the way it is. Would y'all like me to get rid of the negative? Is that okay with everyone if I get rid of the negative? Or leave it as is? I'm asking you. What do you want?
Whichever is easier.
Well, what's easier is what you're going to remember, I guess. So, let me ask you this. If I took this and moved it to this side, would it become positive? Yes? If I took this and moved it to this side, would it become negative? If I took this and moved it to this side, would it become negative? Yes. So if I took all of these things here and moved them to the right side, they would all just change signs, wouldn't they? And then what would be left on the left side? 0. What that means is that when you have an equation set equal to 0, you are allowed to change the signs of everything. You just can't, but you can't just change this one. I can't just change that to positive. I'd have to change that to positive, that to negative, that to negative. Does that make sense? That's the same thing as factoring out a negative. That's the same thing as multiplying both sides by -1. There's so many different ways you could look at it. I think I'm just going to switch it like this. Is that okay? Or is that too much?
Does that only work when it's 0?
That only works when it's 0. What I've done, imagine me moving all of these things to the other side and making them positive. The left side becomes 0, and then I just rewrite it backwards. This is easier to factor. If it works. Does it work, though? Does that factor? So what would you have in this little thing here? What would be your numbers? -3 and -4. Can you come up with two numbers that multiply to be this and add up to be this? 3 and 1. 3 and 1 would multiply to be +3. So one of these would have to be negative, right? So I could do that, or I could do 3 and -1. These two would work to give me this, but would they add up to be this? No. Any other? -3 and -1. Those two would add up to be this, but they would multiply to be what? +3. That doesn't work.
So is that prime?
It's prime. We can't factor it. But what can we use? Remember, when we said prime, it just meant that we couldn't come up with the numbers. It did not mean it cannot be solved. Because now we have the quadratic formula. All right? So that's what we need. We need to use a quadratic formula here.
Could we skip that part and just go straight to the quadratic formula?
Yes, absolutely. Yeah, everyone, the comment was just made and I totally agree with. You could have just completely skipped trying to factor this, and you could have gone straight to the quadratic formula.
So we don't need factoring anymore.
Well, no, you do still need factoring. If this wasn't an equation, you can't use a quadratic formula. So we still need to know how to factor, but for these problems, when we get to this point, we've got the formula. So using the quadratic formula, QF, I'm going to say my solutions are x equals negative b plus or minus square root b squared minus 4 times a times c all over 2 times a. Now notice that my a, b, and c here in this formula are not the same a, b, and c as up here. Why? I changed the signs. I'm still going to work off of this equation right here. You could use a quadratic formula on this, okay? You could. But we switched it. I'll just leave it like that. And now I just plug things in. So here was negative b plus or minus b squared minus 4 times a was 1. C was negative 3 and 2 times a. So I cover up the minus sign and I say to myself, what's 4 times 1 times negative 3? Negative 12. I'm going to subtract it. So 4 plus or minus square root 16 minus negative 12 all over 2. Minus a negative is the same as plus. What?
28.
Oh, I thought you said 23. I'm sorry. All over 2. And those, this represents 2 answers. Yes? Yeah, the square root of 28 can be broken down. All right, now pay close attention. What is our goal here? Why are we doing this step? To find the x-intercepts, right? Those x-intercepts are numbers on the x-axis. We need to know how to graph those. And if we leave this as a root, we're not going to be able to know where to put these things. In the previous problems that you were asking for homework, we would want to break this 28 down, as what, 4 and 7? And then, yes, we would want to do that if this was the only problem we were doing and this was all that was being asked. But because we know we need to put these points on a graph, I'm actually just going to get on my calculator right now and take the square root of 28. So everyone can do that? What is the square root of 28? 5.29. All right, approximately, right? I've rounded a little bit here. Over 2. And remember, when you take the square root on your calculator, the square root's gone, right? You did the square root. I've seen people do this, and then for some reason, they'll write that again, and then they'll take the square root again. I've just seen it happen, so just be careful. Once you do the square root of 28, the root's gone. And now we figure out what these 2 answers are. So do you remember me doing this? I'm going to take the plus case here. I'm going to take the minus case here and figure out what each of those come out to be. Does that look familiar? I'm out of room. Come back over here. So if I do that plus case and the minus case, the plus would be 4 plus 5.29 over 2. The other one would be 4 minus 5.29 over 2. I need to put these together first. That's 9.29 over 2. Here, negative 1.29 over 2. So I do 4 minus 5.29, I get negative 1.29. Now divide those on your calculator, and we'll have 2 answers, right? 4 points, it's about 4.65-ish. And you're going to probably ask me, like, well, how many decimals should you go out? 1 or 2, that's it. Okay, think about it this way. If I asked you, if this is the number 4 and this is the number 5, and I asked you to put a dot at the point 4.65. Right here in the middle, that's 4.5, isn't it? 4.65 is a little bit to the right of that. But are you really going to be able to be that accurate with this? Not really. You can't go into the 100th accuracy on a number line. It's just not possible. So 4.6 is close enough. Make sense? Okay, so what about this answer? What's this one? Okay, negative 0.65-ish. And that's it. We're done with the x-intercepts. Now you can write these as points or you can just leave them like this. If you write them as points, they'd look like this. 4.650, because remember the y-coordinate is 0. Negative 0.650. Those would be our 2 x-intercepts. Those are 2 more points I could graph. All right, that's step 5, I think. We're done. Step 6. Y-intercept. Now, will we have a y-intercept? Yes, always. How many will we have? 1. 1 always. And how do you get it? You set x to 0 in the equation. So that means the original equation was this. I forgot what it was. Plus 4x plus 3. I'm going to replace, I'm going to let x be equal to 0 in this, and I get y equals what? 3. Do y'all notice that when you go to find the y-intercept, if it looks like this, these are always just going to go away? It's always going to just be that constant? It will be. So, as a point, this is written 0, 3. That's your y-intercept. Because 0 went in for x, the y value came out to be 3. All right, that's it for step 6. How about step 7? Is that the sketch?
Yeah.
Sketch time?
So you weren't using the other formula right here?
Which other one?
Change the signs?
No, I went back, excuse me, I went back to the original. Now, the reason why is because when we switched the signs, that only worked when we had the equation equal to 0. Okay, this one, the equation is not equal to 0 anymore. Pardon me? Quick sketch, all you use is the vertex and if you open up or down. That's all your... Remember how it did this? And it opened down? That told us we had to hit twice. If it had opened up here, right, then I would have skipped step 5 because I wouldn't have had any x-intercepts. So I would have never went and set that thing equal to 0 and tried to use a quadratic formula because I know if I did, I would get i's in there. But I can tell by looking here. So it kind of saves us time.
So if you didn't have an x, would this one still be 0?
If I didn't have an x-intercept, you would still do the same thing here for the y-intercept because you're guaranteed a y-intercept always. All right, well, oh, I'm drawing. Okay, step 7. All right, so we want this picture to be pretty good. It doesn't have to be perfect, all right? But we do want to mark things out and kind of measure things out. I know that my vertex is at 2, 7. Now, let me show you. Don't write this down, but you don't want to be like 1, 2. Like, use the space you have, all right? But also keep track, what are your x-intercepts? What are your x-intercepts? Negative 0.65, and then what? Was it 4.6? So you want to be able to make sure that you don't say like 1, 2. Why wouldn't I want that? Because my x-intercept's over here at 4. So you look at your information first before you start drawing your picture. That way you have some idea of where to put stuff. I'm going to say that this is... I'm not going to say anything. I'm going to start this over. I want at least to go out to like 5 here. So 1, 2, 3, 4, 5. Let's say that's 5. And then up, let's see, 1, 2, 3, 4, 5, 6, 7. I want to go to at least 7, right? Because that's where my vertex is. Also, just so everyone knows, when you graph something, all right, this is going to come up when we do some word problems. If I draw a graph and I say that this is 1, 2, 3, 4, right? And I do the same thing here, put dashes like that. I do not have to say that this is 1, 2, 3, 4. I could say this is 5, 10, 15, 20, 25. In other words, 1 unit this way does not have to be equivalent to 1 unit this way. However, 1 unit here has to be 1 unit the whole time. So you can't go like 1, 2, and then say, okay, and this one's 10, and then I'm going to start counting by tens. You can't do that. All right? Okay. All right, so I'm going to put my vertex first. My vertex is at 2, 7, right? So out to the right, 2, up 7, and put a dot there. I'll label this. Notice I'm putting the label above the vertex because I know it's going to open down, so I didn't want it to run into my graph. My X-Intercepts. Negative 0.65, right? Well, here's negative 1. Do you agree? Negative 0.65 should be a little bit more than halfway. So maybe about here. And I'll just draw a little arrow coming off it, and I'll tell you what that is. That's negative 0.650. My other x-intercept is 4.65. So here's 1, 2, 3, 4, 4.5, a little bit more. That's 4.650. I have one more piece of information to put onto this graph before I draw it. The y-intercept. The y-intercept was 0, 3. That means 1, 2, 3, up 3. We good? Now when I draw this, this should look like a U. Okay? Should be nice and curved, no corners. And I should also have this thing we call the axis of symmetry. I should have like an imaginary dotted line that creates a mirror image over that line of this parabola. So I'm going to draw it now. I'm going to draw my little curve up here first. That way I don't forget that it's curved. And then I need to go through that point, down like that, and try and like mirror it over. It does not have to be perfect, all right? That's good enough. Those are arrows. Okay? That's it.
Where do you use this side? I get it.
You got it? Sure. Here are some things that I've seen happen that should, if you're doing a problem on a test or something, and let's say that you had this. Let's say you had this, this, and this, just like we have here, right? Kind of. And what if your y-intercept came out to be there? What is that telling you? You messed up. You messed up something. Because there's not a way for you to draw this and it look like a parabola if you have to curve back in, right? So that would tell you there's something wrong. Also, if you get something like this, right? Those are your two x-intercepts. Something is wrong. Because then your u would have to look like, I don't know, like this. And you don't have your axis of symmetry, do you? That doesn't look like a mirror reflection of itself. I know y'all laugh at this, but I'm only showing you this because I've had people turn that in. And so if it looks weird, you need to just double check your work. Because it should look, with all your information, it should look like a parabola. All right. Let's do one more and then we're going to talk about a word problem. How about this? Y equals negative 3x squared plus 18x. I'm going to go quick through this, all right? Here we go. First step, is it a parabola? Yes. Second step, opens up or down? Down. Look, I'm just going to do this instead. I'm going to just draw a little down parabola so you know that it opens down. Why is it down? Because A is negative, right? Okay, so third step, vertex. I need to find h. H is negative b over 2a. What is b? 18. So negative b would be negative 18. Over 2 times a, what's a? Negative 3. And so you have negative 18 over negative 6. Which is? 3. Okay, what do we do with that?
Now you gotta find the k.
Find the k. So to find the k, we take that answer and we replace the x in this formula with it. So be careful there when you plug that 3 in. It's negative 3 parentheses 3 squared plus 18 times 3. What do you have there? 3 squared is 9, right? 9. 9 times negative 3 is negative 27. What's 18 times 3? 54. So if you take negative 27, you add 54, you get 27. Questions? Vertex is 327 is the point. 327. Is everyone good? I know I'm working through this one a little quicker, but I'm trying to get to what I want to talk about here today. What am I doing? Step 4? Picture. Quick picture. So I'm going to go to the right 3 up 27, right? Again, I don't care really how high that goes. All I care about is that it's up there. Because if it opens down from there, how many x-intercepts will I have? 2, just like the last problem, right? So on step 5, I need to go find them. I'm going to have 2 x-intercepts. And to do that, I set the original problem equal to 0. I replace the y with 0. Now, I told you last time that the quadratic formula will work, right, all the time? And it will, right? If you don't like to factor, you can just go to the quadratic formula every time. If you did quadratic formula here, what would a be? Negative 3. What would b be? 18. And what would c be? 0, because there's no c here, right? There's no number by itself. Or you could look at that as being the number by itself. Feel happy to do that if you'd like. But if you go back to the 3 cases, remember there was the case where there's no x term, there was one way to factor. If there was no constant, there was another way to factor, and if all 3 of them were there, we had another way. Look at this one. It's missing the what? Constant. This is one of the easiest ways to factor, because you just do GCF. That's all you have to do, greatest common factor. What do these both have in common? 3, I'm going to say negative 3x. Right? They both have a negative 3x in them? And so if I pull out negative 3x, what would be left here? X minus 6. Careful, because negative and negative would have to come back to get your positive. Equals 0. All right, once it's been factored, the whole goal of factoring is that now what you do is you set each of these factors equal to 0. So I'm going to set up 2 problems. I'm going to say negative 3x must be 0. And the other problem is x minus 6 must be 0. See, this is going to go a lot faster than the quadratic formula would have gone. What is this? X is equal to 3? What is that? 0. All you have to do here is divide both sides by negative 3. Goes away, you have x, and then 0 divided by anything is going to be 0 still. Except 0 over 0, but we don't talk about that. Okay, and then over here, x is 6. There are 2 x-intercepts. We could look at them as points, 0, 0, and this one, 6, 0. Remember, these are our x values. 0, 6 is our x value here. The y values are 0 because they're x-intercepts, so the y value is always 0. Step 6. What's the y-intercept?
0.
Yeah, you plug in 0 for x into this, and you just get 0, don't you? So y is 0. So that's the point 0, 0. X-intercept are here. These are x-intercepts. This is our y-intercept. There's our vertex. We have everything we need. Sketch time. So looking at the x values, what's the widest I should go here? I need to go to at least 6 on the x values, right? How about the y values?
27.
I need to go all the way to 27, don't I? So when I draw this, I'm going to keep that in mind. I'm going to just draw it like this. 1, 2, 3, 4, 5, 6, 7. I'll just go to 7. That way we have a little bit of room on the side. And then when I go up, I'm going to count by 5s. Okay? I'm going to go something like this. 5, 10, 15, 20, 25, 30. Where do I start when I'm plotting these things or graphing these things? Vertex is where I start, but it actually turns out it doesn't matter which one you do first. I just like to go in the order that I got them. So I'm going to start with 327. 1, 2, 3. Here's 3 up 27. We're going to kind of ballpark this, just visual. And the way that I make sure that everyone knows that it's the right point is I label it. See, that's why it's important to label, because if your graph doesn't have that exact number on it, then you want people to know you got the right thing. All right, so 0, 0. 0, 0.
The X and the Y.
That's where the x and y meet each other, right? This is the origin point. And that turns out to be both the x-intercept and the y-intercept, isn't it? Okay, because it hits the x-axis and the y-axis. Then the other one is at 6. And that's all I've got, right? That's all I've got. So if that's all I've got, does that look like at 3? Not really. Move that over just a little bit. Okay. Yeah. There's my axis of symmetry. I'm just going to draw a U through here. So. Oh, wow. That's terrible, but I'll accept it. Good enough. All right. What do you think? Think you can do that? Think you can handle that? All right, so you are good to do your homework now. The homework starts on page 69 and ends on page 71. There are 8 graphs there for you, so work those through.
When are we taking, or when are we bringing in the
On the day of the test, who emailed me about they needed the copy of the factoring thing? Someone emailed me and said, I need the copy of the factoring thing.
That homework?
The one that you're supposed to turn on the day of the test?
Okay, yeah.
No, I guess they're not here today? Okay. You know, I'm gonna pass a sign-in sheet around. I have totally slacked on this. Let's do that today. I really have been happy with the attendance in this class. That's why I haven't really done much with it. Page 69 to 71. Please initial next to your name. Pass that around. It's, I think I left the column open, right? It's the 11th. Okay. All right. Are we ready? I want to do one application, yes. It's scheduled for like late in October, I think, or early November. It's a ways off, isn't it? We might move it. Yeah, I think as soon as I'm done with quadratics, we'll look at the next section and see how far I want to go into the next section.
Please go to November.
Yeah, maybe just the section right after quadratics. We'll talk about the test after that one. So maybe in 2 weeks or so. I think y'all are ready for a test, aren't you? Like, you feel like this is enough material yet? We have factoring, we have solving quadratic equations, we have graphing quadratic functions, we have word problems, then we'll have polynomial functions, and we're supposed to have rational functions also on there. So there's a lot that could still come on this next test. So we might want to push it up a little bit so that we have less material. All right. Oh man, 20 minutes. This class is just not long enough. Well, I know for you, you're happy with how long it is. Applications. All right, I'm going to give you, there's so many different applications that we have when it comes to quadratic functions and quadratic equations. Remember we were throwing markers around the room the other day, and then I was telling you about satellite dishes and all these different things, right? So there's many different things that we could do when it comes to applications. I like to do one specific application because most people pay attention when I talk about it. All right, so we're going to do a little science project in here real quick. I need to borrow somebody's textbook. Anyone have a textbook from a different class with them? Nobody has any textbooks? No one has a textbook? Yeah, that'll work. That'll work. Here, I'll come grab it. Oh, thank you. Okay. Ooh, this looks expensive. I won't break it. I won't break it. Okay. All right, everyone, you ready? Science experiment?
Origami? Or?
Yeah, we're going to do some origami. A crane? No, it ain't happening. I can give you an airplane. That's about it. Okay. All right, so I'm going to drop the two of these. All right? So I want you to think about which one's going to hit the ground first. Don't say anything. Just want you to think about it, and I'm going to do it, and let's see if you're right. Ready? Set? Go. All right. I don't know if y'all could hear that, but this hit before this one did. Were you right? Yes. Okay. Now, the question is, why did the book hit before the paper hit? So hold on. You have your own idea, right, of what you think it is. And then we will talk about what it is. You want to raise your hand, so go ahead. What do you got?
The book hit faster because the paper has more air resistance to it.
Okay. How do you mean?
Like when you drop the paper, since the book has more mass, but everything falls at the same rate due to acceleration.
Okay.
The book was able to go past the air resistance, whereas
So you're saying it has something to do with the air, not the actual weight of the book?
Yeah.
Okay, so, all right. I heard another person say weight. So I'm wondering if there's a way that I could convince people one way or the other here. If it's not the weight, right? If it's not the weight that's making this drop faster, then, and it is the air, then maybe there's a way I can make the air not be here. I can't do that, okay? So here's what I'll do instead. I can put the piece of paper on top of the book. Now, if you think that the book drops faster because it's heavier, right? If that's what you think it is, because it's heavier, then what should happen is that as I drop these, the paper should, because it's lighter, should go slower and break away from the book like that, shouldn't it? If it's because this is heavier, that's what should happen. If it's because of the air, then they'll drop together because the book is going to push the air out of the way and this paper won't be affected by the air. Does that make sense? So what's it going to be? Oh yeah, and we didn't plan this beforehand, right? There's no tape or glue on your book holding this on here, right? Okay, so here we go. All right. So the book did not fall away from the paper. And what that shows and proves is that on Earth, all objects will fall at the exact same rate. But air has an impact on that also, all right?